Good evening, ladies and gentlemen. This is Kino from Kino.com, and today we are going to do our weekly thing with a standard instrument for flight training. If you are a Army ROTC cadet, college level, and you want to go into aviation, or if you are a warrant officer candidate, you're going to have to prepare before you do that job. You're going to have to take the standard instrument for flight training, which is a test administered by the Army. So every week we're here for people. All you have to do is bring your test prep book. And, as you go through your test prep book, you'll have questions. I don't understand this. I don't understand that. Typically the books, they'll say, okay, well, here's the answer to this question. And then basically, that's it. Oh, answer B. But you may need to know why it was answer B. So that's where I kind of fill in the gap. So we are on Facebook and YouTube. And for people that are providing, hold on one second, guys. Okay, there we go. All right, so people that want to actually see the questions worked out, you should be following me on the live channel. And for all you guys on YouTube, I will definitely drop a link. And you guys can join me over there. All those questions will be posted on the posting board. You can also post questions if you have them. Okay. And in the future, for people like if you can't make the live session, you can also email me the questions and I'll answer them. All right, I'm floating through this now. I just want to make sure that I am not covering stuff that we covered previously. Alright. And bear with me, folks, because, there's a lot of questions to go through, but I kind of sift through them because I don't want to cover stuff that I've covered in the previous session. And, if it is a question, then you should probably go to look at one of the previous sessions. Okay. Okay, the question Facebook has changed some things up. And okay. And I'm trying to navigate through all of that. All right. So, okay. I'm figuring it out. Yeah, it's something like changed as recently as yesterday because I didn't even see. Okay, so. Okay, the upward bending of rotor blades resulting from the combined forces of lift and centrifugal force is known as what? Translational lift. B, blade flapping. C, the Coriolis effect. D, dissymmetry of lift. Or E, coning. The upward bending of rotor blades resulting from combined forces of lift and centrifugal force is called coning. All right. Also, what I will do is rotor blades coning. I will insert some images. All right. At STEMwithKino.com. Parked helicopter. Now, the first thing I'm going to show you an image of a parked helicopter. And what you will notice is that the rotor blades are drooping. Right. Because the blades are not producing lift. And here's a nice one. All right, I'm going to post this on STEMwithKino.com on Facebook so you can see what's going on. So yeah, with Facebook, you gotta hit this create post button, and you know it's my young folks who say they're doing the most right now. Okay, so I'm on Facebook on the channel on the post, and I've just shown you or given you a coning question, but the reason why the blades cone, if you see the parked helicopter, the blades are kind of like, they're just hanging out, they're hanging low like that. So when the aircraft or the main rotors, they start to produce lift, not only do they, when you're in a pre-takeoff condition, they're like straightening up, right? And then I'm gonna put up another photo for coning, and then you're gonna actually see them flex upward a little bit. I actually have a video where I slowed down. There was a helicopter flying by, and I slowed it down. All right, and you can see that the blades were actually flexed upward. So that's coning. The things that cause it, two things cause it: lift and centrifugal force. So let's be crystal clear about that, boys and girls. All right. Yesterday, we talked about Bernoulli's principle. And Bernoulli's principle states, as the velocity of a fluid increases, its internal pressure decreases. As the velocity of a fluid increases, its internal pressure decreases. Now, what does that mean? Blah, 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 blah. That's what he said. Okay. The device that we use to, and I'm sorry, guys. Okay. So the device that we use to demonstrate Bernoulli's principle is something called a Venturi tube. So it's a tube, but a Venturi tube has a constriction built into it, or a squeeze point, if you would, in the middle. Okay, so if we were to measure pressure and velocities at point A, point B, and point C, something very interesting would happen. Now, Daniel Bernoulli, who was the Swiss physicist that came up with Bernoulli's principle, didn't even work with airplanes. It's probably, I don't know how many years before, and I don't want to say the year. Don't quote me on this, but I think somewhere around the 17 or 1800s maybe. But anyway, he worked with water, and what we know now is that water and air behave the same way. All right, so the pressure will be like kind of like at a normal state, and the velocity will be kind of at a normal state. So let's say we had 14.7 psi here, and we had a speed of 100 miles per hour of this flow of air, and then we put a sensor in here. What you will find is that 7.2 psi and let's say 120 miles per hour. Now, I'm exaggerating the numbers just to kind of give you, like a feel of, okay, wow, it really sped up here, and the pressure dropped. As the velocity of a fluid increases, its internal pressure decreases. So that's not going away. When you guys go to Fort Rucker, they're going to ask you, what's Bernoulli's principle? Not nice like me, though, probably. But, Bernoulli's principle states that as the velocity of a fluid increases, its internal pressure decreases, and this is the device that we use. It's called the Venturi Tube. All right. I'm going to post that on the posting timeline of STEMwithKino.com on Facebook as well. So make sure you guys check that out. Even then, before that, let me see. I got some new messages, So, okay. All right. Okay. Oh wow, Breezy, Nicole. Oh man, Breezy. Yeah. Okay. So, all right, we just discussed Bernoulli's principle, and I am checking out more questions. All right. See here. Looking. Okay, we have a math problem. Math is my thing. And, but we answered this math problem in a previous stream. So check out the previous stream. Every week, the new thing is answering new questions. All right. So the previous stream, we already answered that. All right. Let's see here. I'll always do like a distance, rate, and time. I don't care what I do, because that's a lot of people have issues with that. All right. So, yeah. Somebody says, so just do a distance, rate, and time. There's so many types of distance, rate, and time problems. It's crazy. And if you are going to be an aviator, you're going to probably need to be an expert at distance, rate, and time. What's your ETA? How long is it going to take you to get there? So, all right. So let's say we have a basic distance, rate, and time formula. Okay, basic distance, rate, and time formula would be something involving distance equals rate times time. This is like the base formula, distance equals rate times time. Okay. We either want to know how far something is, how fast it took us, how fast we're moving, or how long it's going to take us to get there. But you do have to understand on the test, there are variations. You could get a delayed departure. You could get a round trip. You could get what I call an expansion, which are two vehicles leaving each other, or compression with two vehicles coming towards each other. Or you could get a multifaceted one where you'll have two vehicles leaving each other, but this guy leaves at 12 o'clock and this one leaves at 1 p.m., an hour later. So then you're going to have to make adjustments for that hour. All right. So, and there's no issue. I do them all, but just try to be a little bit more specific. All right. Because, I have tons and tons and tons of questions, but it's okay. I can hunt something down for you in the area of distance, rate, and time. I'm going to find a really nice one. So, okay, let's take the round trip, for instance. All right. On the Facebook post, I am putting the round trip example. Okay. Let's come on back. Post Okay, so here is the round trip example. And this is a round trip. How do we know this is a round trip? And we have to read, folks. People don't like to read anymore. Okay, but this is a round trip. A round trip. A cruise ship made a trip to Guam and back. That tells you it's a round trip. Once I know that it's a round trip, I do a little thing here where I will say arrow out, RT equals arrow back, RT. All right, so this represents a trip going there, and this represents a trip coming back. So as I read through the question, I'm looking for the rate and time going there and the rate and time coming back. So I'll read the whole paragraph in its entirety. Okay, a cruise ship made a trip to Guam and back. The trip there took 12 hours, and the trip back took 9 hours. It averaged 20 kilometers per hour on the return trip. Find the average speed of the trip there. So the average speed of the trip here is there. We'll call that X. It's unknown. They didn't tell us. The time there, the trip there took 12 hours. So I'll put a 12 there. The rate back is 20 kilometers per hour. I'll put a 20 there. And did they give us distance or time back? Yeah, the trip back took 9 hours. All right. So let's make this algebraically friendly. 12x is equal to, now a lot of you will go 20 times 9. Don't do that. If you know 2 times 9 is 18, add the 0, 180. Done, 180. Okay, and then long division, you're gonna have to refurbish, or you're gonna have to go back to long division by hand, like we used to do in elementary school, because you won't have a calculator. It's not allowed on this test. You have to do it by hand. All right, so 12 can't go into 1, but 12 goes into 18 one time. 12 times 1. 12, subtract, 6 drops, then the 0 drops. 12 goes into 60 5 times. So x, or the trip there, x is equal to 15. All right. So that's 15 kilometers per hour. All right, and that was our round trip. For round trip, RT, trip going there, equals RT. So when you look at these math problems sometimes, or the distance, rate, and time problem in particular, what's going to happen is you're going to have to look, what kind of distance, rate, and time problem am I looking at? Go to your formula. RT equals RT. You can draw the arrows if you like. I do it, but you don't have to. RT equals RT. All right, and then execute. So read through the question. What kind of problem is this? Once you know it's a distance, rate, and time problem, grab your formula you're going to use and then execute the problem. Plain and simple. All right. Let's see here. Okay. Send questions, and even if you guys can't be here, we're here every Saturday, 2 p.m. And you guys can also send email questions or put them on a post throughout the week, and I'll address them as we roll along here. Okay. Oh, cool. Yeah. And that's another thing, guys. Even if you are preparing for the AFOQT, which is the Air Force and the Army officers take, you can send math problems. It's not a problem. I'm not going to be, oh, this is not particularly for the SIFT, so I'm not messing with you. No, don't feel free. And my ASVAB people, even if you're not going to be an officer, you're going to be enlisted. I'm the expert. Seriously, I am the expert. I'm not saying it to like, oh, I'm bad. Yeah, this is an interesting one, and I think everybody should know this type of problem because a lot of people have trouble, working with numbers. So, all right, here comes the post. And again, for my YouTube people, the link to the STEMwithKino.com page is available. Okay. We love flying, and it's not just about the aviators for people that want to fly, but it's also about like our naval surface warfare officers, our combat systems officers, and things of that nature. Math is going to be a valuable tool, and you know, if you know math, you know how to follow rules and you understand logic. And that's why a lot of these jobs, they'll give you a test. If you're going to be making X amount of dollars a year, they're going to be like, okay, well, how logical is this person? So math is always a skill. Now we all go out to a restaurant. We go and we go eat, and we gotta be like, okay, well, how much should I tip the waitress? Now the standard average, because waiters and waitresses are paid like, I don't know, depending on where they are, kind of low, like because they get cash tips. So I think some might make $3 an hour or something like that or whatever. But it's customary to tip. Okay, so we posted a picture of a question. Okay, and I'll read through it. A restaurant bill without tax and tip comes to $38.40. If a 15% tip is included after 6% sales tax, how much is the tip going to be? So we have $6.11, $5.76, $5.15, $2.30, and $1.15. Okay, so what you do is, all right, your bill, $38.40. And we're trying to figure out a tip. All right, now, you can burn a lot of time by calculating 6% of $38.40. And then once you get that, then you add it to the tip. Don't do that. If we want to know what the tax is on a bill, all right, we're going to multiply by 106. Why 106, guys? Because 1 represents 100% of the price, and then 6 represents the sales tax. So when we do the multiplication, we're going to have our new total. So we're not finding out, what's 6% of 38.40, and then, okay, now we know what this is. Now we're going to add it to 38.40. Just do the multiplication, and the new answer will come out. 6 times 0 is 0, 24, carry to 2, 48, 50, carry to 5, 23. Filler 0, 4, 0, 0, 0, 0. Double filler, boom, 3, 8, 4, 0. So it doesn't even take that long. 0, 4, 0, 7, 10, carry to 1, 4. We have to count for 1, 2, 3, 4 decimal places. 1, 2, 3, 4. Okay, so the new price after taxes is $40.70. All right, $40.70. That is the new price. All right, so this is the original. After taxes, we've added 6% sales tax. Now, for all my guys, if you want to know 10% of any number, just slide the decimal over to the right. All right, so this is the new number, because now on the new total after taxes, we're going to need 15%. We want to know what 15% is. So this is your bill. This is what your bill came out to, and they will already have calculated your taxes if you're looking at the 6% sales tax. So at this point, we want to know 15% of this. Now, you can do two things. You can multiply by 1. You can multiply, because we're just looking for the tip, not the whole price. You can multiply this times 0.15, or we could do a rough estimate, because our multiple choice answers are spaced pretty far apart. So if you want to know 10% of any number, slide the decimal one place to the right. So $4.07. What's half of 4? $2. Okay, you just estimate. All right, $6.07. That's the estimation. So A is the answer. So while I am teaching you how to calculate, I'm trying to teach you how to do it efficiently, because the clock is going to run out on you. So that's a life skill everybody should know, or have an idea, because they could cheat you. Somebody could cheat you, Be like, yeah, if they do your bill by hand or whatever, like the waiter could be evil and be like, look, I'm gonna add $3. You know, they do that to every bill. You know, it could pile up. So no. Okay, is requesting more info. Okay, let me see. Let's take a look. I'm just checking messages as we go along here. Okay. Very good. Mark, I see you, buddy. I see you, and you calculated it right. And that's the cool thing about the Facebook post. Like, I'll throw up an answer. You can answer it if you know it. So, shout out to Mark. Thanks for coming out. Breezy. Nicole. All right. All right, I answered that in the previous one. And the previous live posts are on the posting board, so, you know, make sure you check that out. Because I've done that question before. Getting a lot of repeat questions here. I've done mixture problems before. Yeah, mechanical comprehension. Okay, yeah, mechanical comprehension. That's a good one. Shout out to, and when you send me questions, I will not say your name unless you say, doesn't, you know, in the post, it doesn't, not in the post, but when you DM me, if you say, I'll just assume you want to be anonymous. If you want your name stated, just say you can state my name, because I just don't want to put people out on blast or whatever. Okay, there are 3 methods of heat transfer. 3 methods of heat transfer, and this is for the mechanical comprehension portion of the test. You should understand that there are 3 methods of heat transfer. I'm not going to say it again. I probably will. 3 methods to heat transfer. Okay, let's say, and what I mean by heat transferring from one object to another. All right, so 3 methods of heat transfer are convection, conduction, and radiation. Convection, conduction, and radiation. Okay, let's say we take a little trip to the beach. All right. It's 6 o'clock in the morning. You know, we go outside, watch sunrise or something like that. All right. And we're in a parking lot. We can lean on our car. All right. Now let's fast forward to 12 noon. It's like 90 degrees outside. Are you going to lean against your car? No, you're not going to lean because it's going to be super hot if it's 90 plus degrees outside. And now, how did the car heat up? How did it get that hot? Okay, well, it got hot by, and this is my attempt at the sun. Okay, the sun sends out solar rays to your vehicle. Okay, and rule number 1, guys, we never laugh at my artwork. Okay, we never laugh at my artwork. I'm very sensitive about it. But radiation. The sun is radiated, or sent sun rays out. Solar radiation to be exact. So at 6 o'clock, we can kind of like hang out, or if it's nighttime and the sun's down, we can kind of hang out. Sit on a car even, but you're not going to do that at noon on a 90-degree day. Now, ouch. How did you know, or what did you feel if you were unfortunate enough to lean on a car? Okay, conduction. Conduction is the method of heat transfer because you directly touch something. Or when your mom's cooking and she, I don't know, making some casserole or cornbread or something, and she wants to move the pan around or whatever, and she touches it. That's conduction. Okay, you're conducting heat. You're touching. All right. Radiation, conduction. Convection. Most of you don't know, but you conduct convection ovens. You have what the hell is a convection oven? You know? Well, did you know? And here's my son again. And flat Earth. There's a. I'm not laughing at you guys because there are what we call flat earthers that don't believe that they believe that the Earth is flat. And everybody's entitled to their opinion, because when back in the days, in the old days, when they said that the Earth was round and people thought the Earth was flat, you know, that was like heresy. Like, what? You really said that in public? You know, there were factions that would like come after you to kill you or lock you up because you weren't teaching what was widely accepted. So you were going against the grain. All right, I don't want to get too far off into this, but when I think about the flat earthers, I think about this when I'm teaching convection or convective activity as it applies to weather. Okay, so this is the surface of the Earth. Okay, make it real good. Mama Earth. All right, so boom, this is the equator. Okay. So we have like the polar regions. The North Pole would be up here. The South Pole would be down here. Okay, and make sure I'm getting all this. Okay. Now, what is the hottest area on the planet? It's the equator. If you live in the equatorial regions around the world, it's hotter here than anywhere. And there's also a little tilt during summer and you know, the Earth, it tilts because it's on different sides of the sun. So in our wintertime, like say in Jersey, the northern hemisphere is very, very warm because it's on that side of the sun. But right now it's wintertime. So the equator is kind of exposed and up when we talk about a line of sight from the sun. So the major solar radiation strikes here directly. Now, the areas of the Earth that don't get as much solar radiation are up here towards the polar regions. Okay, so if you're in the North Pole, the South Pole, all right, it's cold there. Not only because it's a longer distance. Okay, so the radiation is going to lose some radiation over distance. Look at this band of solar radiation. And then look at this band of solar radiation. Okay. Look how wide this is, and look how wide this is. All right. So this band of heat of radiation has less effect because it has more ground to cover. It has more to warm up. If you have a really, really big room and a little small heater, it's going to take forever. So this is like a small heater in a really, really big room. If you have a really tight cubicle and you have a little heater and you enclose it, it's going to warm that thing up. So this is why it's warmer at the equatorial regions more so than the polar regions. Now, as a result, this is what happens. I'll break this in blue. The equatorial regions, and let's here, I'm going to draw a line here to represent our troposphere. Our troposphere is the lowest level of the atmosphere. And it will actually kind of be like that. Sorry, guys. All right. So the troposphere is the lowest level of the atmosphere. Right. So we strike, when the solar radiation strikes here, like your mom's convection oven, the heat rises, right? And then it shears off here. And then as it gets to the polar region, the air is actually going to get colder. So I should have made that, but no worries. And then it's going to fall, and then it's going to circulate again. And it's going to go through the same process. All right. So this is why it's warmer at the equatorial regions. But what this does is it drives, or what we call a circulation of, I'm sorry, wrong way. Heating, warm, rise, cool, fall. Heat, rise, cool, fall. Heat, rise, cool, fall. So there is a circulation of air continuously, and down here it's doing the same thing in reverse. All right. So that's what we call convective activity in weather. All right. So that is the third method of heat transfer, convection, and I know that was a lot. Now you say, okay, well, you were just talking about the oven. Okay, well, Mom, she touched without oven mitts. She touched the casserole or cornbread or, whatever she was baking as far as a cake. Not only that, boiling water. When you boil water, you have your pot. We're looking at it from a side view. Now, typically you have a heat source, but if we had one flame, because now if you look at most burners, right, they're kind of like out of the edge. So this is why you will see the heat rise there. But if we have one burner, like inside, it's a Bunsen burner. All right, let me do the colors properly. Although it's over 100 degrees, it's warmer, cooler. So this is where the water will bubble up in the middle. And then go to the outside. Let's do a different color now. Although this is cooler, you got to think of it relatively. All right, so the colder water in the pot will go like this, and then to get back over the heat and drive it again. So that's convective activity. Same thing happens in your oven. The burner's pretty much in the middle, and that's where the heat is going to be concentrated. So if you really want to, get the maximum baking effect, you want to probably put it in the middle, so the convection can flow through the pan and everything, and blah 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 blah. So I know that was a mouthful. 3 methods of heat transfer are convection, conduction, and radiation and stuff. So that was good. That was a good question. Really, really good question. Probably have time for one more, as it is 8 minutes. Actually, you know what? I should give you some more time because I did start a little bit late. So I ain't gonna cheat y'all. All right. Okay. A physics question, and make no mistake about it, guys that are prepared for the SIFT, you will need to know about kinetic energy, potential energy, the work formula, the acceleration formula, the displacement formula. I said work. Power, the power formula. You will need this. It is in the test pool. It is in the test pool. So don't think I'm just going to read the book, because I get a lot of people. I've read the book, man. I bought 3 books. Still didn't get to square one in, because the books alone are not going to make it happen, folks. You need to understand test taking strategy. All right, that's my little brother. Just sent me a message. Give me 1 second, guys. I'm going to go see my little brother later. Lisa in the house. All right. Good to see you, Lisa. All right, guys. I'm sorry I'm sending my little brother a message. People like that are so unprofessional. All right. Shout out to my little brother, my little baby brother. He's a grown man, but he's always going to be my baby brother. Remember when he first came home from the hospital, a little terror. Nah, love my little brother. All right, back on track. We had a family interruption. Okay, so what was I talking about? Okay. Yeah, there we go. All right. I remember now. All right. All right, posting proportions and ratios. Okay. I'll get into that next, and we do have more time. So, and there's also a point, Mike, and thanks for reminding me. There's a point I want to make as well about a lot of these proportion and ratio problems that we come into contact with on the test, and hopefully my little brother to check in. That'd be nice. All right. I'm not even going to stop it because I'm going to check it out on YouTube first, and you got to let it roll. So we'll elevate it. There we go. All right. I just hit the volume thing. Yeah. Lisa, don't text me while I'm doing it live because that music comes on. And it's all right. I mean, thanks for checking with your boy, just checking on your boy. But all right. No, post. What's on your mind? Okay. All right. Here's the question. And bear with me, guys. I'm gonna get all this YouTube. I'm gonna stay with this because at first I was like, man, I don't like this. You know, I'm juggling 2 channels, and you know what I mean. Oh, Mike, like my ringtone. Thank you, buddy. All right. So the question is posted. All right. The question. Oh, actually, no, it wasn't posted because I didn't hit post. Told you I fell on my head a lot when I was a kid. What's up, man? Why won't you post? All right. What's on your mind? Boom. Bang. Post. Really? All right. I think. Right. Maybe they're trying to limit my. Okay, this is posting. All right, good. Okay, so yeah, I thought we had some issues. Yeah, at first I was like, you know, I'm not going to do this on Facebook, but it's nice when you guys can post pictures and I can post pictures. You can't do that on a Google Hangout. Well, you probably can, but then it's gone forever. Okay, so my resources for all the pilots, civilian and military, that want to, you know, get into this business, or industry, I should say. All right. So a cannon fires off a ship up towards a mountain range, neglecting air resistance. What will the velocity, when or where will the velocity of this projectile be greatest? So it's like when you fire a weapon, okay, boom. The fastest that the projectile is going to be is when it leaves the muzzle. That's where the energy, just like, let's say if somebody was coming towards me and I boom, I shoved them. Like the more motion, where they're gonna experience the most force is like when I grab them and you know. So that's where, you know, the most force is gonna be produced. So the answers are exiting the muzzle halfway to the mountains, or as the projectile impacts the mountains. No, the most energy it's gonna have, or where the velocity will be greatest, is when it first leaves the cannon or whatever. I'm assuming this is like a Navy destroyer firing a cannon. So yeah, that's when it's going to be, the velocity will be the highest. That's a good question. And Mike made a suggestion. Okay, proportions and ratios. Okay, a lot of times what people don't understand is they don't understand proportions. All right. So let me give you an example of a proportion. I have one right here. All right. I'm posting. No, that's percent, Kino. What's wrong with you, bro? Okay. I talk to myself, but I don't answer back. So I'm not a danger to the public. Okay, so I'm posting a proportion problem right now. And if you're following me on Facebook, I keep saying that because my YouTubers need to come on board. Okay, so I've just posted a problem. All right. And it is question, it's labeled number 3. You have 9/6 equaling x over 10. All right. Okay. This is how we see proportions. 9/6 equals x over 10. Now, this times this divided by this will get us our answer. This by this divided by this. Because this times this equals this times this. All right. And hit a 1 if you understand what I just said. This times this equals this times this. So 6x is equal to 9 times 10, which is 90. Okay, 90 will be divided by 6. 6 goes into 9 one time. 6 times 1 is 6. 33, 30, 15. So x is equal to 15. Okay. Why is this a good skill? I'll show you. Why is this a good skill? This is a good skill because, oh, it's snowing. Wow, okay. I'm going to have to bundle up later. Little bruh, snowing. Okay. Why is this a good skill to have? Because you're going to get a lot of multiple choice answers like this. All right, I'm just going to make one off the dome, like they say, right straight off the dome, son. Okay. Kair can eat. No. Kair walks 5 miles in 10 minutes. All right, so we'll say Kair walks 3 miles in 10 minutes. All right. What they're doing is they're setting you up. They're giving you a standard. Because Kair can walk 3 miles in 10 minutes. Okay. And you set up a standard. Okay, miles, minutes. Miles over minutes. So Kair can walk 3 miles in 10 minutes. So I'm automatically, when I see that, when I'm reading that through the question, I'm already, boom, I'm setting up my proportion. Okay, we can walk 3 miles in 10 minutes. How many minutes can Kair walk in an hour? So that's the question. Kair walks 3 miles in 10 minutes. How many minutes can Kair walk in an hour? Well, miles, minutes. There are 60 minutes in an hour. Okay, now you can cross multiply and divide, or you can just directly multiply. You can look at the difference between 10 and 6. We multiply 10 by 6. All right. And we look at this. If we multiply 3 times 6, which is 18, boom. And it's also an equivalent fraction, guys. 3/10 and 18/60. They're equivalent fractions. Okay? So a lot of times, that's why proportions are so awesome. And knowing how to use them, you can apply them. Once they give you a standard, okay, Katie did, I don't know. I'm trying to get another question. I can't think of one. Because the real questions keep coming at me. But, all right, Katie ate 2 pieces of candy in 5 minutes. How many can she eat an hour? Katie, you don't even know like candy. 3 pieces of candy in 10 minutes. No, 5 minutes. She ate 2 pieces of candy in 5 minutes. So that's going to be the top part. And then I'm going to ask myself, well, how many can she eat in an hour? 2 hours? 3 hours? All right, 1 hour? 2 over 5. 60 minutes. Okay. 120. 2 times 60, 120 divided by 2, 10, 24. She's going to eat 24 pieces of candy in an hour. Okay. So, if you're a manager, your team can get a project done in, how many days? So there's so much you can do with proportions. It's crazy. We talked about the first class lever system in a previous live stream. So the last thing we're going to touch on is what we call the second class lever system. A second class lever system is one of 3 types of lever systems in mechanical comprehension. We have 3 classes of lever systems. There's a class 1, a class 2, and a class 3. We've talked about the class 1. And I'm sorry, folks. Gotta stay hydrated. It's with all this cold air, man. All right. So, the class 2 lever system is a system, and I'll write them all, but today we're going to talk about the class 1. The class 1 lever system is the seesaw. You probably didn't know because we all played on seesaws, but the middle of the seesaw is called a fulcrum. F-U-L-C-R. Okay. R-E-S-P-E-C-T. F-U-L-C-R-U-M. All right. So the fulcrum is in the middle, and you might have the kid over here and the kid over here. All right. But we label one side the load and the other side the effort. Okay. So the fulcrum is in the middle. In our second class lever system, the fulcrum is positioned on one side. All right. So the fulcrum is here, and we have the load in the middle and the effort on the outside. The best example of a second class lever system is a wheelbarrow. A wheelbarrow. A wheelbarrow. We got a wheel on the end. We have a bucket in the middle where the load is placed. And then we got ourselves producing effort upward. Okay. So that's why the wheelbarrow is the best. You guys that are in landscaping or like to plant your own flowers, you're probably gonna have a wheelbarrow somewhere to carry some stuff down. So why are we even talking about this? A wheelbarrow is a simple machine. A simple machine takes our effort that we put into it and it multiplies our effort. So we don't have to do as much. The leverage is going to help us out. All right. So second class lever system. Now, I am going to go into some examples next week because we're kind of running out of time. I don't want to run over. I wanted to make sure I gave you guys a full hour. Even though we started late. And keep in mind, sometimes things come up. Like Facebook, they had this whole different thing where they changed up. And they're just like, would you like to go back to old way? I'm like, yes, I'd like to go back. Keep it simple. They came up with this stuff like YouTube does. That's why I only do lives on YouTube anymore. I used to do live streams on YouTube, but you got to have your OBS. You got to, all this, it's just too much. Just make it simple. All I want to do is provide information for my followers and stuff like that. So for me, hey, I'm already teaching physics, calculus, algebra, and stuff like that. I don't need to learn not that I'm opposed to learning, but I'm like, look, keep it simple. That's the message of Facebook and YouTube. Keep it simple. People, we don't need to hire a guy from Channel 10 News, to help us out. Oh yeah, you got to do this. You got to look at your filters and no, I don't want to do that. Okay, so let's help make our job easier. So again, I will be here next Tuesday, 2:00. All right, and hopefully I will be on time because YouTube and Facebook are not doing all kinds of weird stuff. Let me give shout outs, okay? Because everybody that checks in, I really appreciate you guys taking time out to come check me out. Andre, I see you, bro. Lisa, thank you for checking in. Nabria, Breezy, I'm going to say Breezy. Breezy, thanks for checking in. Nicole, thanks for checking in. Michael, thanks for checking in. And anybody I missed, question-wise, people that provided questions for this live stream, I thank you guys for checking in. Every little bit helps because the majority of the populace, they don't want to, they're really not trying to elevate or move forward or move ahead. Like, I think about this, I'm working with a soldier right now, and he's on deployment. I'm not going to say his name. All right. But the beauty of life is when you're in difficult positions. It's a beautiful thing. When you guys get in difficult situations, and I rarely go here, but I thought about this young man this morning. But when you are in difficult situations or you're uncomfortable, that is the most beautiful thing that can ever happen to you. It is a test, and yeah, we don't like it. I get that. I've been through some pretty rough times myself in life, but it's the most beautiful thing in the world because you get to center. Yeah, you go through it, you get the disruption. Oh my God, I can't believe this happened. Oh my God, your friend won't talk to you, whatever, or whatever, blah, 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 blah. But everybody that's preparing for this test, you're uncomfortable. You want to get somewhere. You want to get to, I want to be an Army pilot. I want to be a helicopter pilot. I want to be a surface warfare officer in the Navy. I want to do this. You're uncomfortable where you are, and you want to get somewhere else. Okay. But I was thinking about this particular soldier that's deployed. And all you guys that are on deployment, that is the best time to prepare for one of your military aptitude tests of your shit. Damn it, I lost. Okay, well, my YouTubers, I believe I'm still up. Okay, we actually had a power interruption. Okay, I'm gonna let people talk about it, but yeah, so it's okay. We're still rolling here on YouTube. Okay. So back to my point. You realize, like, listen, I want to do something, I want to be something. You are not comfortable in your space. And, you're willing to do something about it. So you're probably going to have to go through a couple months of discomfort. Because who wants to be calculus, physics, or, kinematics and mechanical comprehension and levers and gears and pulleys and stuff like that. Nobody wants to go through that. And, it's just something that we have to do if we're trying to get somewhere. So that's all I have for you guys. And I don't know, I try to stay away from that life stuff. I try to keep it, on that. But I was just thinking about this gentleman and stuff, and how he is actually applying himself to change his life and make something happen. Because obviously you say, hey, I don't want to do this, I want to do that. So there's a need inside you, like, okay, I want to do that. And you figure, what do I need to do to get that done? And, that's where I was going at, because, a lot of people in your circles, they don't understand. They're comfortable with where they are. They don't want to, like, no, I'm good. Just doing this job, I'm good. But they don't want to elevate. And so when you want to elevate, there's a need, or you're like, no, I don't want to do this anymore. I want to do that, or I want to elevate. So never, ever stop pushing when you're trying to elevate yourself to get something done. Okay, so that's it. I'm Kino with STEMwithKino.com. Thank you for watching, guys. I really appreciate everybody that checked in. And we've had some type of power interruption, and it's okay. It'll be back on in a sec. And I'll see you guys. So stay tuned for videos coming up, upcoming live stream. I will be back on at Saturday, 1400. Thanks for watching. I'll talk to you guys later. Bye-bye.